Okay, this is my Ozert or spike style heater in basically finished form. I'll obviously modify it to get it to run better later. Had to modify the holes. You want it to run not too rich but not too lean, so I beefed up some of the holes in the actual lower burn chamber, made them a little bit larger, and then obviously the lowest rung in the burn manifold is larger, and then the upper ones are more, and that way you get a better combustion to help mix the air. You can see that I swirled it, and it actually does make it swirl a bit inside, which is obviously for your combustion. The biggest issue with this design is, though it burns cleaner, you're throwing your heat straight out the stack. So inside here is, I took a rotor and it's sitting on 10 head bolts, sitting about 10 inches off the actual where the manifold, the burner manifold meets into the bottom of this, which I can show you at another time. I'm obviously not going to do it right now. And that helps disperse some of the heat, but it's not directly in the flame. It touches the very end of the kiss of the tip. And that way you still get a good burn, but it transfers the actual heat around to the external surface. I noticed an increase in temperature a little bit. I mean, right now it's been running probably about a half an hour. This isn't the most, I mean, with the Mother Earth version, it ended up getting to 1,000 degrees on these surfaces, but I was also throwing a lot of soot out of the chimney. Whereas with this, I'm not, which I will show in a minute. I mean, this is maxed out at 1,000 degrees. I'm sitting at 890, and it's just increasing, which I will max out here probably in the next hour. This one does burn a heck of a lot more oil. However, I feel that this one is a lot safer than the Mother Earth style, where the flame can be blown out by the air. There's stacked directly out and further up, which I had to paint it black to get an actual good read. And then if you read up here, obviously the temperature drops a bit. Some of that is because of the actual regular furnace, but also because when you try to read galvanized, for some reason it reflects a lot of the actual temperature that you're trying to read. This is actually my feed for just regular air to conduct through. It just draws cold air up through the chamber, which it heats through the actual shaft inside. The fan's not hooked up. And then these do the same thing by pulling cold air from the floor up. I went from 1/2 inch line to obviously a fuel filter to help pull out some dirt, debris, and that is your standard old fuel line. You know, in your old Mr. Gasket quality stuff you could buy at any parts store. I took the filter piece out and then drilled out the hole in the top and the bottom, and that way I can watch the fuel dump, or I'm sorry, the oil, waste oil, but at the same time not have it miss a line and then drop something out of it, and you know, you walk away and the next thing you've got a big oil mess. And this is down to 3/8 line with a 3/8 needle valve. Now this is not one of the high-end fancy ones. It's about a turn, a half turn gets you basically running pretty good. A full turn, you're running well. The biggest thing is you gotta start with your holes small and plan to modify from there. Don't go too large because you don't want to throw too much heat through the stack, but at the same time you don't want to go too small and stick with that. Now this is internal reading, not external, and it is obviously still climbing. But this gives you just kind of a base estimate. Obviously the surface temperature is not exactly the same as internal temperature. But it was at 8 something now. You can see I'm at 951 and basically still climbing. This thing will chutter in the beginning, you know, puff a little bit out of here, but it seems to draw itself back in. I start with mine with kerosene and just a little bit of toilet paper, let that burn off, probably about a cup. And it, honestly, this just seems like a very safe way to run this. Between the two that I've run, I ran the Mother Earth one for probably about 4 years, and it made so much soot. No matter how much you messed with it, you always ended up with soot, or the wind was blowing and it would put it out. This one, you know, I've had some windy days, and it just doesn't seem to mess with it too much. You get a little bit of a draw, but nothing that'll actually blow out the flame. Obviously, I'm still in the tweaking stage, but the holes that I put in today, the larger holes, which are, I don't know, about 1/2 inch. I didn't even look at the size drill bit. I just went up. The original ones were 1/4 inch, and these are probably 1/2 inch all the way around the base, all the way around the top, and then I have 3 holes that are 1/2 inch, and then 3 holes that are 1/4 inch, just to help with the burn. It seems to be making a difference. Obviously, you want to go out and see the stack, so I'm not going to feed you through the shop because it's messy, but I'll walk you over there. I'm going to pause it for a second so I don't kill myself walking. So here's the footage again. It's a little dark, but there is minimal smoke. You see a little tiny, very faint puff every once in a while, but you don't really see much. This is the cleanest it's honestly burned, with the most fuel that I've pushed through it at one time. Like I said, it's a constant stream, and it's burning clean. Obviously air is the decider, but too little and you run rich, and too much you burn too fast and throw too much heat through. So that's why I say start small and work your way large.